Welcome to this explainer. Okay, today we are finally moving way past those basic, fragile generative AI demos. We're going to unpack exactly how to build a scalable, secure, and truly production-ready AI layer cake right on AWS. It's all about architecting enterprise-grade systems that won't just fall over the second real users hit them.
So let's dive right in. What we have here is a full-stack roadmap that traces the actual life of a request. We'll literally follow a single user prompt from the front-end interface, right through the API and security layers, into orchestration, and all the way down to custom machine learning silicon and safety guardrails. It's the whole shebang.
To keep things digestible, we're breaking this complex ecosystem into 6 logical parts. 1. Access and security layer. 2. Bedrock and foundation models. 3. Agents and orchestration. 4. RAG and data stores. 5. Multimodal and custom ML. And lastly, 6. Safety and observability.
All right, part 1, access and security layer. We start at the very edge, right where the user actually meets your AI system. This is where you lay down your primary defenses. The golden architectural rule here: never, ever expose Amazon Bedrock directly to your end users. No way. Instead, you've got to put API Gateway right in front of it to act as your bouncer. It handles auth, validates incoming data, and manages usage plans. Without this gateway, you're risking a massive cost explosion from unchecked API hits. And that brings us to a massive mindset shift for production AI. You have to rate limit before inference, not after the invoice. This is an absolutely crucial senior insight to remember. Generating AI responses is computationally expensive, right? So controlling your costs really means stopping those bad, malicious, or overly frequent requests at the gate, long before they ever wake up your expensive foundation models. Moving on to part 2, Bedrock and foundation models. Once we're securely past the bouncer, a request hits the real cognitive engine of the application. The key takeaway here is that Amazon Bedrock isn't just one single model. It's your entire AI access layer. It gives you a single, managed API to tap into multiple foundation models. So whether you're using Claude, Llama, Mistral, or Amazon's own Titan and Nova models, Bedrock makes switching models incredibly easy from day one. You don't have to rebuild your whole infrastructure just because a hot new model drops next week. But taking this from a hobbyist demo to full production means entirely changing how you talk to these models. You see, a bad prompt is just a messy, unstructured chat request that gives you wildly unreliable outputs. A production prompt, though, that acts way more like strict interface design. You're using structured system contexts, few-shot rules, and demanding strict JSON output schemas. You're not just asking for text anymore, you're asking for reliable, parsable data. Now, when you're selecting an AWS native multimodal model, take the Amazon Nova family for instance, you don't just jump straight to the biggest, most expensive option. The real pro move is to always start with fast, small models like Nova Micro for your basic text tasks. You only escalate up the curve to Nova Lite, Pro, or Premier when complex reasoning is genuinely required for that specific task.
All right, part 3, agents and orchestration. An AI that just talks is neat, but an AI that actually takes action, that's a real game changer. To make our AI do things, we have to orchestrate workflows. And here is the core agent loop in a nutshell. First, the AI gets the user goal. Second, the agent goes into a reasoning phase to map out a plan. Third, it reaches into an action group, like an API or a Lambda function, to execute a task. And finally, it takes the result of that action and formulates a final answer back to the user. But listen, we have to be incredibly careful here. You never give AI agents unlimited access to your databases or APIs. Instead, you use the Model Context Protocol, or MCP, to connect agents to tools safely. MCP servers act as these secure, highly scoped gateways. They make sure the AI only has exactly the permissions it needs, and maybe most importantly, they maintain strict audit logs of every single action the agent tries to take.
Next up, part 4, RAG and data stores.
This is where we cure that notorious AI amnesia and connect foundation models to your private enterprise data using Retrieval Augmented Generation, or RAG. Now, building RAG from scratch can be a total headache, but Amazon Bedrock Knowledge Bases brilliantly manages the whole flow for you. It pulls your raw documents from an S3 bucket, chunks the text, creates the mathematical embeddings, and stores them securely. Then when a user asks a question, it seamlessly retrieves the exact right facts to ground the AI's answer. And please keep this absolutely crucial tip in mind. RAG quality starts with clean documents. If your source PDFs are a messy, poorly formatted disaster, well, your AI's answers are going to be a disaster too. Plus, when you're trying to improve search relevance, smart metadata filtering, like tagging your chunks properly, almost always beats just feeding the model larger, noisier chunks of text.
Under the hood, your RAG architecture really needs the right databases. You're going to want Amazon OpenSearch Serverless to scale your semantic vector searches without having to constantly babysit a cluster. But vectors aren't everything. Right alongside it, you need Amazon DynamoDB acting as your serverless NoSQL memory. That's what keeps your chat history, user state, and session routing incredibly fast and low latency.
But what if your data isn't just text documents? What if it's a complex web of information? For things like mapping out fraud rings, customer 360 views, or tricky IT troubleshooting, standard vector RAG might actually miss the context. This is exactly where you upgrade to Graph RAG using Amazon Neptune. You use this when the specific links and relationships between entities matter way more than simple keyword or semantic matches. That brings us to part 5, multimodal and custom ML. Because real-world applications don't just process text prompts, do they? They handle invoices, audio, images, the works. So instead of trying to force a foundation model to do everything from scratch, smart architects leverage AWS managed services as a pipeline. You've used TextRack to pull structured data from forms. You use Comprehend to detect and redact sensitive PII. You use Transcribe and Poly for real-time voice loops and recognition to moderate visual content. You process all of this before the data ever reaches your core GenAI model. But what happens when those off-the-shelf foundation models just aren't cutting it for your highly specific proprietary use case? That's when you escalate to Amazon SageMaker. Think of SageMaker as AWS's true machine learning operating system. It really separates the AI hobbyists from the ML engineers, giving you a totally comprehensive environment to train, deploy, tune, and rigorously govern your entirely custom models. And if you're building custom models, you need the right hardware to back it up. For maximum efficiency at scale, you'll want to run these customized models on specialized AWS silicon. You use AWS Trainium chips for super cost-effective model training and fine-tuning. Then, once the model is ready, you deploy it onto AWS Inferentia chips, which are built specifically for high throughput, low latency, real-time inference. Finally, part 6, safety and observability. This is literally the most critical production requirement of them all. Our request's journey ends with the seatbelts, and you simply cannot launch without this layer. Amazon Bedrock guardrails sit right at the model edge to filter out malicious prompt injections, block toxic content, and check for hallucinations. Meanwhile, tools like Amazon CloudWatch and AWS X-Ray provide that crucial observability feedback loop. They let you monitor latency, track failure rates, and keep a very close eye on your token costs. So there we have it, the full stack blueprint. We've traced the entire path from a fragile script to a robust, enterprise-grade AI application built for the realities of production. The tools, the security layers, the orchestration engines, they're all sitting right there in the AWS ecosystem. So ask yourself, your current GenAI demo might work beautifully today on your laptop, but is your architecture genuinely ready to scale securely into 2026? What are you going to build first? Thanks for joining me on this explainer, and I'll catch you next time.